kick it off. And we're going to go ahead and get started. Here's the camera. For anybody online, if you have questions, please drop them in the chat and we'll relay them and work our best to get those answered. Wanted to give Bill a minute to come on over here. Here's our camera. No.
Oh, you mean over here?
Yeah, this way.
Okay.
That camera.
That camera.
Yeah, your other left.
Thank you. Yeah. I'm Bill Higgs. Among other things, I'm the Vice President for the local ISACA chapter. Next Thursday, a week from today, we're meeting at KPMG and we are holding our elections. So all offices are up for grabs. If you go to ISSASD.com, you can get our website, they'll give you the details. The meeting is at 11:30 at KPMG UTC. And like I said, we are, we're ready for some new leadership. I've been here too long. So we want to get some more people in. So anyway, I hope you can attend and spread it to others. It's a good chance. It's a good opportunity for leadership and to get back.
Yeah, and I think it's a great opportunity, not only for maybe people that are kind of seasoned, but for anybody young, up and coming that wants to get some leadership experience and that sort of exposure in the community. So can definitely work to take advantage of that as well.
All right, thank you.
Awesome, sure, thank you. We'll go ahead and kick things off. I just want to let everybody know we have next month's event up on the calendar with the registration. I'll get it opened up tonight. I just ran out of time. But we're going to shift gears a little bit next month. And there are 2 students that are graduating college that have that are majoring in cybersecurity, and the chapter has sponsored their membership the last couple of years. We've had the opportunity to see them learn, grow, and they're literally going to graduate May, walk the aisle in June, and watch the student loan invoice bills start to come in July. So we're just going to take some time to have kind of a roundtable with them, ask questions, and let them share their experience. So that's what we'll be covering next month. Super looking forward to that. I've also got these for anybody that hasn't heard me share it. The chapter is doing a collaborative endeavor. It's a 5-series online webinars on how to secure a home network. They're not designed to be super technical. They're totally open to the public. So anybody that's interested, we encourage you to log on, check it out. They're on Zoom. I'll pass these out. They've got the dates for them. Totally open to the public. Do not need to be a member of any organization. So even if any of you have that family member that can benefit from it, please let them know about it as well. Other than that, Aaron, I'd like to let you come on up. Yes. Oh, you're going to start already?
Yeah.
I'm sorry, Jack. Yes, you had a question?
Yeah. I was going to make a plug for what you were doing on that, but I just changed my mind.
No. Please continue. Yeah.
No, actually, I've attended them, and yes, they're not very technical, but what I've been able to do with them is transfer some of that information to my other family members. So I just wanted to put a plug that they really are useful, especially from an audience like this. You can then send it out and then talk to your family members and friends and explain something. So they've been great. I've enjoyed them, and continue to plan to attend them.
Awesome. Thank you. Thank
And
you.
you'll pay me later.
Yes, in cash, like we discussed. Yeah. Cool. Hey, come on in. Come on up.
Sure.
So I met Aaron, I don't know, half an hour ago, in person,
But the
but
other guy from Lincoln.
yes, yeah. Exactly. But one of the coolest things is when we put it up, we had a lot of registrations, a lot of interest in you and what you were going to cover. So it's super exciting from where I sit, just trying to put together value-added presentations for the members and the community at large. So kudos to you and what you've done prior to that. And from there, I'd just like to turn the microphone over to you, sir.
Thanks very much, and thanks to everybody for having me. Always great when we can kind of introduce friends to friends. So hopefully we can continue sharing things together. The experience I kind of want to talk about today is cloud security. I haven't always been doing cloud security, and I'm going to tell you a little bit about that tale. It's nice to meet you all. So we're going to talk about around a decade or so. I'm going to kind of start a little bit ahead or behind rather on the origin story of cloud and how that came to be. And then kind of bring you all the way up to now. So a pretty big swath of time. And hello, nice to meet you. I'm Aaron, and I run a cloud security consultancy here in San Diego with my wife, Marcia, who's also here today. So yes, it's a husband-wife team, but that works for VMware and for Cisco and other companies you may not know. But people always ask us how we work together, how we can tolerate that. My answer is it's because each one of us is convinced that we are the bigger burden on the other. So it works for us. And before we were doing this at ScaleSec, I was at AWS in the early days of 2013 through 2015. I was one of the very first cloud security consultants there, so I got to work with a lot of kind of the early adopter enterprises, and that's a lot about what we're going to talk about today. And then before that, I was kind of a logging nerd. I really like to look at events, and got the Splunk shirt on, I appreciate today. So I worked at a competitor, a different company called ArcSight, which got gobbled up by HP. And then before that, I was here in town building managed security services for SAIC. Got to do some fun work there too, and tell you a little bit about. Based here in San Diego, right? So hopefully we get to, even past this talk, please connect and I'll try to get out in the room, I guess is the way I would say that. So, I know there are a lot of different.
We're getting some people online asking.
Okay.
Closer to
Stand closer. Okay. I hate to hide behind the pedestal, but you know what? We'll do it today. So I know there are a lot of different types of security practitioners here. So I just kind of like to throw up a map and just kind of tell you a little bit about what I focus on. So you kind of know where my thoughts are coming from. I'm definitely not the pen tester. I'm kind of on the other side of the color wheel. We consider ourselves to be kind of like the green team, right? And we sit right in between product and like the CISO tower, right? The GRC and security function. So my focus is shipping secure product fast, right? So that's kind of what I do on a day-to-day basis. The kinds of things that our team is doing today, we're building a global retail payments platform. We've got a new managed service for cloud incident response. We're providing tier 1 engineering support as well for cloud specifically. And this is kind of across all the providers. Launching a global cloud secrets management solution for a big US bank starting this month. And then we're building building security into cloud infrastructure as code as well. So we work with a lot of like platform engineering teams, and they've already got kind of a big function in terms of DevOps, and we kind of stick the security part in there, right? We're going to talk a little bit about that today too. And then the last bullet here, one of the things that we specialize in is taking products to the federal market, right? So somebody who has a commercial platform, maybe a really cool SaaS offering, and says, this might be really cool for the government to use, right? And we get those kinds of inquiries often. And so if you're familiar with a program called FedRAMP, that is one of our specialties, and we do that on all 3 of the clouds as well. So right now we're working with a wearable health device company, a company that's building email security platform, a cloud call center, which is really interesting, combining cloud with on-prem components, bioinformatics, automation and analysis, and software security. The cool thing I think about the security industry is it's not a vertical, it's a horizontal, right? It basically can touch any vertical because everyone needs security, everyone needs to protect things in some way. That also means because cloud is kind of the democratization of all these cool technologies, people like companies of any size can use cloud, right? So we get to work with kind of everybody, which is really cool for our team. They get to move around between lots of different companies and support lots of different diverse environments, which is fun. So anyway, so I'm coming from we're more cloud builders that focus on, we see everything through the security risk and compliance lens, right? So you can think of us that way. All right, let's go back to 2012. Okay, so I'm really having a great time at SAIC and ArcSight. I think I pretty much know everything by this point, right? We're doing incident response, we're doing threat intelligence. We did IT outsourcing for the county of San Diego. So thank you very much for giving me your tax dollars to spend it on this amazing giant equipment carrier class stuff that we got to use and build with. It was a lot of fun. I had a giant toy box. I was studying all the Cisco CCNA certs and things. Got to build these cool SAN arrays and all kinds of neat stuff like that. We did a really big deep dive into ArcSight specifically, which is why I wound up working there. I did a really big deep dive into Archer technology, the GRC platform, and made that do things it wasn't designed to do, which is a lot of fun as well. So I kind of was almost getting bored, to be totally honest. And then I started a new job in 2013. Right. This company reaches out and says, hey, we think you might be interested in this cloud thing. And I said, okay, I kind of heard about cloud, but I've also heard it doesn't have any security. Why would I go to the cloud? And I said, well, that's the opportunity. And I said, that's not a bad pitch. So I'm into it, right? And so in 2013, I learned I don't know anything. These folks are taking boats and they're laying cable on the seafloor to connect the continents together. They're building their own substations because the power plants can't provide power to the data center fast enough. They're rewiring Caterpillar generators because they want to fail them close if they detect an anomaly, right? Because the workload on the other end of those generators is actually worth several thousand times more than the generator itself, right? So they're doing all kinds of amazing scalable hacking kind of exercises that I hadn't really conceived before, right? So, and recently, that's actually a new picture. They just bought this, I think, of Pennsylvania, nuclear power station. So again, kind of learning like, okay, I don't know what scale is. I built data centers before. I dragged cable myself. I had no clue until I got to see some of this stuff that James Hamilton was doing. Pretty amazing. So I joined a little bit late into the cloud journey. It had already started in 2006. So we're going to kind of zoom back real quick and talk about what was going on in 2006. And you got to put your mind back to 2006, really 2004 if you want to count like when a preview service came out. But this is when the first GA, generally available service, was launched by AWS. 2005, they actually had Mechanical Turk, not really a cloud infrastructure service. Mechanical Turk, if you don't know, is kind of an on-demand labor force, right? Before we had things like generative AI that can analyze satellite photos, you might say, if you're a solar company, you might say, find all the houses for me in this picture that don't have solar panels, right? And so someone could actually go around and count all those and add them up for you. So those kinds of little tasks you could farm out, and they would pay, a few pennies per task type of thing. But if you did enough of it, you're making a paycheck, which is kind of interesting. So in July 2006, we saw the first infrastructure service generally available ever for a cloud computing company. Anyone know what that was? Not you. He worked at AWS, so I'm not going to let him do it. Anyone? Okay. Chris?
SNS.
SQS, very close, very close. The simple queuing service, which is essentially just a message queue, right? And the concept there, especially like looking back in hindsight, that was actually a brilliant first release, because that was kind of one of the first things you needed to start decoupling a monolithic application. You really wanted to say, let's have all these components be separated from one another, but let's let them communicate through kind of an intermediary, right? So having an SQS service was actually kind of cool. Honorable mention to Alexa Web Information Service. And I'm sorry for those at home who have canisters that are going off in your house right now, but not this Alexa, right? So there were actually two products at Amazon with that name. The first one is just a web information service that collected information about websites, and that shut down in 2022, RIP. And then 2008, EC2 was launched as a generally available service. It was conceived in, that should be late 2003, my bad. So yeah, 2003. Okay, so first question, we've actually brought some swag here. Does anyone know the birthplace of EC2? Where was that conceived and developed in the world? Yes, Joe.
Seattle.
Good. So yeah, Seattle would be kind of a default choice. It was actually Cape Town, South Africa. So a couple of people there wrote an extensive paper, what was happening there, quick origin story. So Amazon.com was actually building out their retail platform. And then they started to say, hey, maybe we could actually build this kind of retail platform for other companies. I think Target was one of the first possible customers, right? One of the first companies they were talking to there. And so they said, can we actually start building these kinds of platforms for other companies? And sort of towards the bottom of that paper, it said, maybe we could actually just, rent these out kind of as a general purpose capability for people who didn't want to actually build their own data centers, right? It's kind of the last part of that paper, which is kind of mind blowing. That's how all that started, right? And so that picked up steam, and Bezos and other people caught on to that and said, yes, we actually want to start. Let's go see how this part of this runs, right? And so AWS and EC2 were born at that point. So let's do the swag one.
I just.
Okay, that's awesome. Okay, good. So what was also going on in 2006? Just again, so you kind of get your mental model there. we saw the launch of Hannah Montana, not a cloud service. Borat to make a movie film. Let's see, we got the first baby pictures of baby Shiloh from Brangelina, and Pluto is sad to learn is no longer a planet. All that was happening in 2006. Side question, why does Google know how to spell Brangelina? I don't know why that's a thing that Google does, but that's a thing. Good. So 2007 to 2009, kind of the early adopter, kind of use at your own risk cloud environment, right? A lot of people kind of experimenting at this point. There are only just a few of the basic building block AWS services available at that time. There was no VPC, no IAM, nothing you could build large enterprises on. EC2 was if you bought EC2 as the Elastic Compute Cloud, those are virtual machines. You can rent the servers by the hour. That was just directly on the internet. So if you leased one of those computers, it just got a public IP and you could just access it, right? The virtual private cloud was the thing that actually put those inside a virtual data center in the cloud, but that wasn't released until 2011, much later. So again, kind of a little bit dicey, but if you want to play around with it and figure out how cloud works and start kind of thinking about how you can improve over time as the platform improves, still a good time to get in. No real significant security incidents, at least that I could find, unless one of y'all knows more than I do about that, because it just wasn't broadly used, right, for official purposes. A lot of test and experimentation around that time. There were definitely some outages back then, but a lot of those services were kind of beta anyway, and that's kind of par for the course with some of these beta services. All right, so in 2010, things got spicy, right? Because other technology companies said, hey, we can do that cloud thing. And so they started to pop up too. We saw Microsoft build their Azure platform and Google release their Google Cloud, right? So these again, all the dates that you're going to see from here on out are all GA dates. So everyone is kind of beta testing before this a bit, but 2010 is when it got pretty spicy in the cloud market. Amazon not real happy to hear the word multi-cloud, didn't really want to hear that ever again. Although it's part of our vernacular nowadays. You know, most companies are actually using more than one cloud nowadays. Speaking of spicy, also in 2010, Lady Gaga showed us how that we could actually wear our dinner out if we wanted to. I guess you could wear your dinner to dinner with that, which is pretty neat. 2012 was a big step in cloud security, and this slide I'm going to slow down on because this one is super important to understand how a cloud provider works, especially if you come to ISACA and you're thinking about risk and you're thinking about compliance, you're thinking about controls, who does what. This is a type of outsourcing in a way, right? You're essentially asking another service provider to come and manage some of those controls for you, which is awesome because I don't want to dig out pour concrete and put in cameras and put in fences and guards and stuff. Let AWS do that for you, right? So that was very helpful. So down here on the bottom, you're seeing where we're building regions and availability zones and edge locations and the hardware and the global infrastructure that runs it all, right? Those C cables that we're actually connecting the continents together. And then you get some of the basic fundamental building blocks of compute, storage, database, and networking. And then you assemble those into like a software layer so you can start to build your own and compose your own applications using those basics, right? And that's the hypervisor software layer, right, where you can access all that stuff virtually. And so that's the split between AWS and the customer side. The customers then are responsible for all the data stuff, the networking and the firewall configurations, the identity and access management, data security itself, right? So kind of a two-part model, if you will. And it is actually a lot more complicated than this nowadays. This is a very simplified picture that we use back in this era to kind of help customers understand, like, yes, we've done a lot for you, but we can't do everything for you, right? You're actually, you log into the operating system, you have to maintain that, right, on some of these services. And then in 2014, we saw another kind of version of this, which I think made it more accessible to a large range of customers who said, I don't really understand all the bits and bytes, but when you explain it to me like I'm ordering pizza, now I get it, right? Because either you're dining in, you're making everything at home, and you got to go to the grocery store and you get everything from the cheese to the dining table. You have to provide all that. Whereas on the other side of this diagram, you're dining out and you're not responsible for anything other than writing the check, right? Which is kind of more like a software as a service type platform. This is from Albert Barron from IBM, which I thought was pretty great. And let's see. So 2013, okay, so I'm thinking, cool, I'm going to go travel the world. I'm going to meet really cool people. And what I heard right out of the gate was, I do not trust cloud. We were forced to come to this meeting. We don't want you here. We don't want cloud. And one of my favorites is, why are people from the bookstore here? Right? Because Amazon largely was only known as the retail company at that point, right? So nobody really knew who AWS was at that time, which I thought was kind of cool. And okay, there's definitely some doubters, right? And that's to be expected. This is a very new approach to running IT, and you're trusting somebody else to do it for you. And that very first one there, I don't trust the cloud, right? We would actually stop and say, that's an important thing that we want to drill into right away, right? And we'll talk about how attestation and standards and certifications work and how you have independent third parties come see the data center and no, I'm sorry, we can't set up a data center tour. That's not something we do, because all that does is now we're going to argue about should the fire extinguisher be 2 meters or 4 feet away from the door, right? That's not productive. What we need to talk about is your data safe? Are we qualified to actually manage it for you, right? So at the end of the day, I think very much so, especially nowadays, I would definitely want a lot more of my compute and my infrastructure managed by the cloud provider. It means that I have way less scope to deal with, especially in my audits and things. And that's actually how we approach a lot of our FedRAMP programs. Right? We'll take a customer's commercial SaaS environment. We will tear the engine apart down to the block and start over with them and refactor their application, mostly consuming managed cloud services, because that means at the end of the day, when the FedRAMP team asks you, how are you managing this? You say, they're managing this, right? So I don't have to, right? I don't have to actually run all these security scans and manage all this stuff. I'm just managing the application. Right, so more doubters, right? The cloud is not secure. I heard that one a lot. Usually from people who are sitting at a desk that looked like this one. That's okay. We all have kind of our different idea what security means. I don't know what happens when this person goes home at night, right? To that data and those computers that are sitting on that desk. But again, I understand the concern about this. And maybe a little of that was deserved, right? Because if you look at how visibility worked in the cloud, meaning like how do you even know what's happening in the cloud before 2013? That was super hard, to be totally frank. So in 2013 or before 2013 rather, I'm a builder, right? I launch my laptop and I connect to the cloud and I put up these instances, right? I put up these virtual machines and I'm like, this is fun. And then I go to the next slide and I go, hang on, there were 3 blocks just a second ago. What happened, right? You don't know. Before 2013, you didn't actually know, right? The only way that you actually had the ability to do this before 2013 was insert something in your command flow, something to actually log those commands and be able to say everyone has to go through this gateway and no one's allowed to directly connect to the cloud. That way, we're able to log and analyze who's doing what in the cloud environment. And I'm here to tell you those gateway devices were very expensive. Right, because they knew they kind of had a locked-in market, specifically a niche that they really exploited for a long time. 2013, we had a new service that was launched called CloudTrail, and this thing was able to record all the API calls that were being made in your AWS account, either by the user or by some other application, even the other AWS services that were making those calls on your behalf inside the environment, and it would record all those to your S3 bucket, to your kind of your blob store. And then it supported a lot of different products out of the gate, supports even more nowadays. I got to work on this product, which is pretty cool. They said, we pegged you as a logging nerd. Please come talk to us about how we should be logging things in the cloud, which was really fun to actually work on this product back in the day. And so now, when one of my boxes is missing, I can see who is it. I can see that Nikki shut it down, right? And I can go ask Nikki what's up, right? So, but now I'll have some visibility and I actually understand what's happening in my cloud environment. Way better than before, right? And then we have our kind of first right, which is called a company that was called CodeSpaces. And what happened with CodeSpaces, they were running a cloud-based code hosting service. They were actually not quite like GitHub, but kind of like GitHub. And the attacks that happened to them in one day was they had a distributed denial of service attack, which turned out to actually be more of a distraction attack, I think, because at the same time, somebody who had logged into the AWS console, how they got the credentials wasn't really ever determined. But they started deleting everything, right? They just started deleting virtual machines, data, backups, machine configurations, went out of business in 12 hours, right? So like a very sad story and early days again, kind of like people are starting to look at cloud in 2014 and say, can I actually run business workloads here? This was hard to fight, right? I mean, you had to talk about like, well, multi-factor authentication and using the root account to log in. There were a bunch of no-nos that were happening here, but it's time we recognize to start educating customers on how to do this correctly, right? And if you remember, this is kind of our first example of where we saw a breakdown in that shared responsibility model, right? So this was very concerning and something that we need to start educating customers on. And more hate was coming my direction, which is great. Now, I don't know if you've seen that sticker, but it was very popular. There is no cloud, it's just someone else's computer. And that again, understandable how people are concerned about this. And yes, it's definitely someone else's computer, but the mistake I think I see in this still today is that people are comparing a hardware product, something that you buy in a box, with a service that has people that actually manage it, right? So it's not just a computer. There's a whole bunch of people that are actually managing that thing as a service. A service and a product are two different things entirely, right? And so it's the people thing that actually makes the big difference there in my mind. So much so that I made my own version of this sticker. There is no cloud, it's just someone else's audit scope, right? Which is my favorite thing, because I don't want audit scope. I'm trying to get rid of it as fast as possible. Right? So, not well. Good request. Maybe we'll make a run of them. Yeah. So. Good. So in 2014, 2015, that's again where we started to see kind of security insert itself into DevOps. We were seeing a lot of new DevOps shops out there, Chef, up there with lots of different utilities. I think were very popular back in what I kind of like to call Cloud 1.0, right? The virtual machines, the load balancers, the databases and things. And so the big questions here were like, can security solve some of those DevOps challenges? Can DevOps actually solve some of the security challenges? It turns out there's an overwhelming yes to both of those questions. I got to work with Intuit here in town in San Diego. We kind of were working on the very early versions of what we thought DevSecOps would be. We're writing about it and talking about it. I got to talk at reInvent about this, which is Amazon's annual conference. Having your code in version control, being able to perform automated testing of the code that's actually going to deploy the infrastructure, having that repeatability to be able to say, I can test these things out on our infrastructure without it actually being our infrastructure. I can just spin it up again in a brand new account and we can test over there and we will never actually impact this other area over here. Having that repeatability to be able to redeploy the same thing over and over. So we said, let's do all the things as code, right? We're going to do security as code. We're going to write policy as code. We're going to write compliance as code. We're essentially performing change management now through code, which is a huge upgrade from the days that we were actually, I was literally at SAIC typing out Word documents, right? We would print these out. We would turn to page 374 and it's like, click this box, go to this thing, click this box, hit enter, right? Because you had to make it step by step. Super painful to actually write, super painful to follow, even worse to maintain. Right, because you get a new Windows patch would come out or a new software patch would come out, all your boxes move around, options are different, the workflows are different, you got to go change your Word document. Very miserable experience compared to something like this. DevSecOps is the thing that actually powers this Green Team vision, right, of saying, we don't have to focus on all the computers and databases and things we're actually deployed and living alive in the environment. We can inspect how those things will be built if we look at the code. So let's look at the code and focus all of our efforts on making sure that this code is going to produce items that are secure. These cloud resources are secure, that they're configured in the way that we want, right? And as those things run through what we now call a build pipeline, we can put those checks right in place and say, hey, I noticed that somebody decided to add a firewall rule that's open to the world. That's probably not a good idea. Let's talk about that, right? You can take action on sort of those kinds of things. Hey, I noticed that you just went ahead and copied and pasted your password straight into your code. Also probably not a great idea, right? Let's talk about those things. That turns it from a reactive mode of trying to run around and try to stamp out all those fires in a production environment to these things don't even exist yet. We haven't even started our risk window, which is awesome because we're having a very preventative conversation about, I don't want this to get in our environment. Work with me development on how we can prevent this from happening, right? Let's talk about some other places you can store secrets. Let's talk about how to make good firewall rules, right? Let's see if even your team should be writing these firewall rules or if you should be working with a networking team. Let's connect those two teams together, right? So this opened up a whole new era of preventative security that really kind of powers what we do today. Thank you. So the infrastructure trends that we saw, kind of over time as people were using cloud computing, started with kind of Cloud 1.0, I like to call it, virtual machines. We saw Amazon had one, Azure launched theirs shortly, or 2012 or a while after, and then the Google Compute Engine right after that. Containers was a very big, evolution of this, right? Where we had these kind of fundamental underlying technologies like Docker, which was the containerized, the container capabilities, and then Kubernetes, which is the thing that actually lets us orchestrate and manage those containers. And then in April 2015, in July, just a couple months later, we saw AWS and Google announce their managed container offerings. And then same thing with Microsoft Azure, and then Amazon again with the Kubernetes service. Then we moved to functions. And if you remember kind of how big the deal was when AWS Lambda launched, right? That was for developers, that's an amazing thing. I don't have to worry about any of the infrastructure, and I'm not even charged for that infrastructure. The only thing I'm charged for is exactly when my code runs end to end. I'm charged for just that little tiny window of the execution, which is amazing. And then from a security perspective, whole new ballgame, right? What's allowed to trigger this Lambda function? What is this Lambda function allowed to interact with? Is it allowed to stand up databases? Is it allowed to write data, to delete data? How are we going to observe that? We got to put in new libraries and inside those functions to actually monitor what's happening there. So the invocation rules and the permissions that these things have are something that we certainly need to think about now, where we really didn't have to think about that in the past as some of the security experts in the room. And then the workload evolution, right? So this is kind of going again from that big monolith, early days, 2000s, where you had kind of this three-tiered web architecture that I think everyone's pretty familiar with, right? You have a web server, an application server, and a database. Man, those were the days. That was really easy. You just have three things to figure out. Now, a microservices architecture is everything's connected to everything, right? You have what's called like a service mesh, and you got to figure out, which is really cool once you get it working. It automatically encrypts the communications between all the containers, and a whole bunch of other stuff, and authorizes all those workloads to speak to one another on a least privilege basis. So very powerful technology, but again, kind of raises the bar for entry for people just jumping into the field. I mean, the one on the left is super easy to figure out. You got three things to figure out on the left side. But this is kind of the evolution of workload over time. Leaky buckets, 2015 through 2017 was kind of the height of that. If you remember seeing all the headlines that so-and-so, exposed data because they had a public S3 bucket on Amazon, right? Which is that kind of like it's kind of like an FTP server in the cloud, but it's actually a web-driven, API-driven storage service that Amazon has. So I'm not going to read through all these, but I got a couple here that I think are really key examples. The U.S. National Geospatial Intelligence Agency exposing geospatial intelligence data, SSH keys. CENTCOM had a bunch of content and internet histories that for some reason were hanging out in the cloud. The NSA and DoD battlefield intelligence. Accenture was kind of got dragged a bit for having kind of just a big bundle of technical stuff that it was in a public S3 bucket. Technical data had VPN keys and dumped hash passwords. PII from all these other companies. Oh no, I mean the World Wrestling Entertainment Corporation. Yeah, some of these are very impactful, right? And so this was also, I think, a big wake up call for a lot of cloud providers. Hey, we have trouble using this stuff the right way, right? It's kind of the main message that I think was heard for most of these teams that are building these services. And the crux of it all for me was that by default, new S3 bucket settings do not allow public access. So this means people are deliberately opening up these buckets and they're exposing them to the internet, right? So to everybody. And that's really rough to hear. Somebody's making that decision. Well, why is that decision being made? I think this is why. I think Dropbox is kind of an interface that we're all used to sharing data with one another, and we say, well, this is a place where I've just got files in S3. Isn't that the same thing? And I say, absolutely not. Dropbox is really storage for humans. It's storage and sharing data for humans. S3 is for building applications. It's storage for machines, right? But you look at this kind of bucket policy and you go, I don't know how to do all that. I'm just going to open it up, right? And I'm not going to publicize the URL, but then people figured out how to find those URLs and find those buckets and start looking through them, right? And so we saw that big hype 2015 through 2017. Okay, so then you saw in 2017, you saw the very first security usability enhancement for S3 that really tackled this particular issue, which is like, hey, if you're going to do this, it's going to open this up to the entire world, right? So be sure that you want to do this. Good. So even beyond then, we started to see the other AWS services kind of join the band, right? We saw AWS config come out and say, hey, you're going to be able to go check all your buckets. We're going to find where you have this unrestricted public access. We're gonna issue a new service. We're gonna build a new service feature inside of S3 that lets you have just block public access carte blanche across the entire, right? Which is a really cool. Depending on, regardless of what is settings are on each of the buckets, you can do it at an account level and just say no public sharing, right? That solves the problem. You have to go around and find all the buckets and figure out what to do with them. You can override those permissions. CloudFormation, which is kind of their infrastructure as code deployment service, right? The interesting thing I think about this is you got the public access block configuration support. That was just days after the feature was released. And if you know anything about kind of like how the Amazon 2 pizza teams work, they're very small teams that deliberately do not coordinate things with one another. They try to minimize that overhead of communication. This was obviously coordinated, right? So a lot of attention, I think, paid to this particular issue because of all the headlines, right? And then Amazon Guard Duty and started to say, hey, we're going to alert you when this stuff is happening as well. Again, I think very simple, like this particular warning, very clear about what's going to happen, but it still was happening, right? And so we saw even more S3 security enhancements coming out from the rest of the team. Access Analyzer would actually go through and tell you what your permissions are going to be on those buckets. Amazon Macy, and a once awesome team here, a startup in San Diego, Harvest.ai. If you knew them, they were in UTC. They were acquired by Amazon and now built as Amazon Macy. So yay. A 80 to 90% price reduction in the Macy cost, right? So that you could actually go find what's in all of my buckets. I want to know what potentially could be exposed out there. And then, the ability to actually set up criteria to not only scan the buckets I have today, but even buckets that pop up tomorrow. If they have this kind of name or this kind of tag, I want to definitely go scan the contents and see what's in those. Control Tower, one of their awesome provisioning platforms, enabled that block public access. So you start to see this rolled into the other products. S3 then decided to change the security defaults, and this one kind of makes my head turn on end because S3 is a massive global service and it's serving trillions of files per second, right? And what they did is they changed the defaults on that kind of service, which if you can imagine how important that particular service is. A lot of people like to talk about like what is the center of the universe inside of an AWS environment, and a lot of people say, oh, it's compute, it's EC2, and go, I don't think so. Data has gravity. S3 is the center of the universe to me, right? Inside that kind of environment. Anyway, they actually said we're going to change the way that service works by default, which is just amazing because of all of the development that had gone on before that, right? And you basically you have to tell developers well in advance, right? So that was announced in 2022 that that's going to happen, and it happened a quarter later, and it took a whole month to actually deploy, right? So that just should give you some concept of how big a deal that was to actually roll out. But again, this is a very painful problem for customers.
Can you talk for a second about the difficulty from the customer side in configuring these three buckets and why this major customer change happened? Because Amazon's not in the business of disrupting customer business.
No, by yes, anytime you're going to change the default at all, right? It means that the service is going to now work in a way that when you put development horsepower behind it, when you took all the time to write your automation and write your programs to handle S3 and store data there and retrieve data from there in the way you thought it was going to work, now it works a different way, right? And that means that's potentially application breaking, absolutely. And so I'm not familiar with any specific stories there. I just know that thing being kind of at the center of the universe for a lot of those applications, it was certainly disruptive, but a very needed change, right? I actually took some heat on Twitter for suggesting that that's what we do way before that happened. So maybe we should actually change the way that works by default. That's a default change, right? So kind of an uprising. So, okay, that's fine. And then block public access and disable access control lists are now default for all new S3 buckets. S3 has had at that time, it still has access control lists, which are things you can configure manually for who should be able to read and write to this bucket. And then it has a bucket policy, right, which is more granular. It's that JSON document where you can actually write out the differences between there. And so we have a trivia question here. Why did S3 have both of those things? Why does it have ACLs and bucket policies? I'm sorry. User versus network. That's good enough. It's a good enough guess. It's because S3 actually predates IAM, and IAM is the thing that actually gave us those policy documents, right? So we didn't actually have the policy documents. Let's see, 2006 was when S3 was launched, and then 2011 was when IAM was launched. So, a 5-year span of just working with ACLs, and that's the only way you had to configure access to the data in the bucket until you finally got those policy documents. Good. Uh-oh, some more uh-ohs. 2018 and kind of still, we saw this introduction of something called cryptojacking, right? Which is an attacker finds some cloud credentials, is able to access your cloud account. They get in there and they launch these super powerful VMs or these GPU devices, right? Because they're going to go crypto mining. They install their mining software and they get to work and they start mining crypto. The good ones are going to do that kind of quietly, right? If you saw Office Space and they're trying to just round off the transactions, right, and take a couple of pennies and then wound up not doing that, which was, I think, then a nod to Superman 3. But less obvious, it's throttled, but either way, it's going to run up your bill, right? Whether it's immediately or over time. Wow, I don't know why my bill is so much more expensive this month than it was last month. And if people look at that hard enough, the tips here are monitor logs for cloud regions you aren't officially using, right? So if you're a US company and you might not think maybe we should kind of check out what's happening in Japan or Sao Paulo regions because we don't really work there. But if you're an attacker and you want to hide, that's a great place to go, right? And the other one is disable or block cloud services that you aren't officially using. If you don't need GPUs, just turn them off, right? By policy, like put administrative controls to block that from happening. So just allow by default, right? And it's kind of the best practice in every realm of security, including this one. Okay. 27 to 2018, Zero Trust Network is going to fix all of our problems. And I think that's amazing. And the marketing team said, think how that's going to SEO. We need to get out in front with that. And we need to tell everyone what Zero Trust Networking is. And everyone should use it. And our product is the thing that's going to solve this problem, right? So what the heck is Zero Trust? I just want to kind of like try to put this all in one slide for you, okay? So the way we used to do it is we had these colored networks, right? And this was a concept of varying levels of trust for the computers that sat in those networks, right? So we had the super bad no-no zone, which is the dirty internet out here on north of the firewall. And inside we have varying levels of what we consider to be safe, right? We have kind of the orange zone, which is more like a DMZ, where we have the internal LAN, and the guests are kind of sus, but not as bad as the DMZ, so let's make them blue, right? You had to kind of this concept to put them in there. What was great about this is it was very simple to implement. What was hard is that once you're in, right? So once you're in any of these zones, you're in. So we actually have a cool NIST publication for this. You should definitely read it top to bottom. But the basic concept here is that there is no implicit trust that's going to be granted to these assets or accounts based on solely their physical or network location. Like if they're on a local area network or the internet, they're all considered red, right? For the purposes of kind of considering that contemplating that first picture over there. Let's just say everything is red, and let's only allow connections by exception. And we're going to have no implicit trust based on asset ownership either. So I don't care if it's an enterprise asset or a BYOD device, which again, this is well timed because we're starting to have a lot more remote work and people working out of Starbucks and whatnot. So the characteristics of a zero trust environment, we're going to micro-segment into individual resources, right? Because we have this concept of deperimeterization, this thing on the left where we actually used to build the castle and moat, that's going away. People are again, they're kind of working out of coffee shops or their homes. We need to think about just these individual resources accessing individual corporate resources as well. Let's treat them all red, and then from there we can start to make sure that the security connectivity is good. We're not making assumptions that so and so is trusted to connect to this thing. Authorized by identity, not by IP address, right? That's super important as well. An IP address doesn't really give me a whole lot of confidence about who's on the other side of that IP, especially if it's a proxy and there's thousands of people on the other side of that. Permit by access by least privilege, again, kind of a ubiquitous recommendation there for any security environment. Verify explicitly and continuously, kind of continuously being that new step up is like, let's make sure that that person is supposed to connect. Let's make sure that that application is supposed to connect to that database every time it connects. Encrypt end to end. Still kind of see people struggle with that a little bit, especially when you consider the last two bullets together, encrypt end to end and monitor. Right, sometimes those are in opposition of one another and automate all the things, right? So a couple of blanket things in there, but a couple of that are very specific and unique to zero trust. Why are we doing this? It's because we want to combat credential theft, phishing attacks, lateral movement, privilege escalation, insider threats, and data exfiltration. if you think about how, for example, continuously, explicitly verifying those connections, don't let internal systems just wildly connect out the internet. That's not least privilege, right? You need to use least privilege and say, what does this need to connect to and why on the open internet? Because if someone's actually able to break in and exfiltrate that data, if you just left all your egress rules open, we can send whatever we want. ZTA in a slide. I love it. All right, 29, super big oops. Capital One breach, right? This one was a former AWS engineer who knew what they were doing, right? They understood how AWS worked. They understood if I can get into one of these virtual machines, and that virtual machine has access to things like S3, again, the center of the universe. And if I can list all those buckets and then start to look through those buckets for things that I might like to have, first time I've ever seen S3 commands listed in a court file, by the way. It was in 2019, and Marshall will tell you, I sat and I devoured this thing at the family table. I said, this is amazing. It's just like, it changes everything. But the best part about this, there was no evidence that the data was actually used for fraud or shared with anyone else, right? Once that attacker had that information, at least as far as anyone knows, that was not copied or shared with anybody. But the impact, it was definitely a wake-up call, right? 100 million US credit card customers, 1 million Canadian social insurance numbers, 140,000 US social security numbers, right? A big problem on exposure, right? And so this cost them a lot of time and a lot of money. There's class action lawsuit as well. So just a big problem. Anyone know what year that was, right? We are now to 2020. Everyone's working from home. Again, this is a major change for every industry, including cloud, including security, including cloud security, right? So people are now switching to digital entertainment. They're streaming everything. They're playing games. They're on social. They're working remotely. They're collaborating. A lot of e-learning happening because I got extra time. I'm going to go look on Khan Academy and see what I can learn now. A lot of e-commerce happening because I don't want to go to the store, right? And then accelerated cloud adoption and migration, according to all that drive of that new, hey, there's a lot of things happening. It's all happening remotely. What's good for that? Cloud, right? Let's build our applications and put them there. We don't want to drive into the data centers and troubleshoot things. We'd rather just move our applications to the cloud. You saw a lot of remote distributed operations. You saw a lot of good research collaboration. Cloud used to actually help us understand and analyze and fix the problem that we find ourselves in 2020. And new public service announcements and new capabilities that are offered to the whole world, really. This is Coders Against COVID. Our team actually volunteered to build the backend for this, and FEMA was using it, which is really awesome. Which is essentially like I did the very first one. I think we beat Google to the punch on this by like 60 days, where we actually had the first map up where you could actually find a place to go get a test for COVID. 2020, this is also a really big change, especially in our regulated industry for telemedicine, right? This is where we need to kind of troubleshoot things remotely. We need to allow telemedicine remotely. The OCR actually lifted, I haven't seen this before at this scale, they lifted in good faith and allowed applications, even if they didn't meet the HIPAA requirements for security rule, that you can go ahead and do telemedicine over Zoom, Google Meet, FaceTime, Facebook Messenger, Skype, and those kinds of things. And explicitly said, not Facebook Live, not Twitch, not TikTok, right? So they're not going after the socials, they're going after the face-to-face stuff because they really needed a way to be able to get help to people quickly, right? 2020 to 2023, I know I'm squeezing a decade here, so it's a lot of stuff. So secrets on GitHub, right? And this is a lot of different things. This is just regular passwords. This is API keys to cloud environments, which is wow. Access tokens, SSH, RSA keys. By design, if these things get into GitHub, they're actually not easy to get out, right? Because GitHub's whole purpose is to log all the changes that are happening and maintain that log over time, right? So to get them out of the log is actually kind of a complicated thing to do if you're not that technical with GitHub. So a lot of those things would get there and stay there. It's in Python stuff, it's in JSON, it's in environment variables, it's in JavaScript, it's in Docker files, Kubernetes configs, it's everywhere, right? So it's not one problem, it's just kind of global inside of GitHub. And then the top offenders we actually saw from India, China, and USA. This graph here kind of shows that things are getting worse, not better. I would actually say we're just getting better at looking for it, right? I think is really what's happening here. I think we're getting better at detecting and finding that stuff. Git Guardian is one that we actually tested this out just to see what would happen. You put a public key up in there, go ahead and disable it before you do it if you want to test it on yourself. But Git Guardian will actually send you an email and say, hey, we saw this, because they're watching GitHub all the time. I think GitHub does this by default now, if I'm not mistaken, but the best way to do this is prevent this from happening at the first place. 2010s and on, we saw kind of a new distributed denial of service attack against even cloud environments, but those were actually the best suited to actually survive something like this, because again, they're the ones that are laying cable on the seafloor. So they're the ones with the bandwidth to be able to combat something like this and the resources. You can see, like, what was that one there? Google got hit for 2.5 megabits per second. These are just volumetric attacks, the rate attacks. And then AWS got hit for 2.3. Just imagine, like, back in the day, you're running your own T1 line, and you got your own web server, and you're just trying to, like, share your kitty photos online. You're not going to survive something like that, right? So actually, the best thing here to do is hide behind one of those cloud providers. It's even, you won't expect to get billed for that. They can't even tell which customer that's actually destined for in a lot of the cases. Cool. Okay, so trends of how cloud is used over time. We have, and this is kind of small font here, but the usage early days, as I said, was kind of experimental exploration. The security was very skeptical at that time, right? You didn't see a whole lot of security features, and you saw a lot of people with a lot of questions, which is totally understandable. Building in 2014, we started to see building individual business processes and say, okay, maybe cloud is good for this thing, right? Back in the day, I think one of the more popular use cases was, if we have a commercial and it's going to be aired during Super Bowl, right? I need a lot of horsepower all at once, and then maybe that trickles off right after the Super Bowl, right? So, but I need the surge capacity to be able to handle something like that, or an opening day, or something like that. And then you saw the security was very cloud specific. That you started to see this new introduction of enterprise security features that we talked about, like CloudTrail, happening now, so you can see and have that visibility. 2015, you started to see, okay, we're going to see how we can use this thing, but we still have our on-prem environments. We're going to have these hybrid scenarios where we're going to connect this to the cloud. We're going to, I think that was called cloud bursting, right? You can take some of your analytics and your worker processes and run them in the cloud, and then terminate those instances, which was actually happening way early days with Novartis. They did a 10,000 node cluster back in, I think it was like 2010 or something, around the world, which was pretty awesome. And that was like an $8,000 experiment for them, as opposed to an $8 million data center build, or $40 million data center build, I think. So more attention now being given to shared responsibility at this point, because we're saying, okay, if we're really going to start using this thing, we need to understand how it works. We need to understand what our responsibilities are, and help our team understand how to keep this thing safe. And then 2019, we started to see widespread adoption. Really, like, okay, we get it. We actually want to run in maybe a couple of clouds because we like this service over here and that service over there. Which is a very popular thing today. Still doing a lot of hybrid environments as well. You're starting to see security be more measurable and repeatable. Again, I think that's that picking up from DevSecOps and starting to say, let's do this in a way that we can be preventative about it, the way we can measure it. And then 2022 to now, you're starting to see people really optimize at this point. Like they're really kind of going after more of the edge cases, that they're integrating more things together. You're starting to see people focus on cost management. Why are we paying this much for this thing? And it's getting more predictive and more proactive on the security controls. Okay. Cloud compliance trends, kind of from back then till now. Cloud Security Alliance was actually one of the very first ones out to say, like, hey, we need to do something about controls in cloud and get out there first. That they had quite a lead on everybody at that point. I didn't know that until I researched the slide, but now I do, and now you do. And then SOC 2, I think, was a very popular addition to this stack, right? You've got a lot of people that are saying, like, I want to buy the SaaS platform, but I don't know if you're managing this thing well, right? I've looked at the shared responsibility model. I know what questions to ask now. How are you managing your side of the shared responsibility model? If I'm going to use your service and I'm going to put my data as a business in your business, how is your business protecting my business's data, right? So you have this attestation. You have a CPA come in and say, these people appear to be protecting their data in the way that they say they are, right? Which is basically all you get from SOC 2. NIST then came out and said, we're going to tell you what an infrastructure versus a platform versus a software as a service actually are, define what those are, so that the rest of the world can start building material around that. FedRAMP launched in 2011 and said, this is cool. We were doing this all on-prem one at a time, but if we can actually figure out a way to go through this process once and then have other agencies use this inspection, this very difficult bar to pass, and if you must be this high to ride this tall to ride this ride, then maybe we can actually save a lot of money and a lot of time and adopt these cloud services quickly for the things that we need in the agencies. And then PCI jumped in and said, you know what, we probably need to talk about cloud and how you're running your payments workloads in here. They released a couple of things, and ISO said, okay, fine, we'll do this cloud thing. But you know what, we already have 27,001 and 27,002, so we're not going to rewrite that. We're just going to tell you how to use that. And then in 2016, we saw some very specific guidance from HHS on using cloud computing. This is not exhaustive. There's a ton of stuff going on in the compliance world right now for cloud computing specifically. 2023, here we are. Last year we really kind of saw this generative AI and people saying, all right, how am I going to stop prompt injection? How do I avoid malicious training data? How am I going to stop these hallucinations? I'm really worried about the data that this thing has access to. Aside from that, yes, those are things we need to solve. At the bottom here, I think there's a really good opportunity to use this for good, right? Especially combating things like analyzing billions of rows of logs. Again, kind of on the log background, so I know that that's really hard at scale. Anomaly detection therein, right? Looking at that many logs and then saying that thing is weird specifically is actually a really hard problem. Help me write policies, please. I don't want to write these things, especially these system security plans for federal. If they're 1,000-page Word docs, they crash my Chrome browser if I open the G drive. And then incident response playbooks, like tell me what I should be doing. How should I respond to these incidents that happen? And can you look at my code and actually help me, find the security issues inside the code? Can you help me build new code to fix that code? We're seeing not only some cool places where that's actually happening now inside of Git. They'll actually look at your code and send you a pull request and say, this is the change we think you should make to your code to be more secure. Forensics analysis, there's a ton of stuff to dive into there. We wrote an ebook for this that you might like to peruse if you're trying to think about how to use AI securely in your business. In 2023, a big oops. Yes.
If you go back just out of curiosity, what you have in that ebook, can you just share a little bit of what it covers?
Sure. So this is how to use ebook, how to use AI. This ebook is about how to use AI securely for your business, right? So this is covering kind of these use cases over here on the left-hand side, actually, where we're talking about these are things you can do for it. Yeah, our ebooks are pretty meaty. They include some pretty good prescriptive technical guidance as well. So it's not it's beyond the marketing fluff that you might see from some others. So worth a read. Okay, so Microsoft breached by a China-based actor, right? So now we're starting to see kind of nation state really espionage at a government level, right? The foreign government going after Microsoft specifically, which is interesting. You may also be familiar with SolarWinds, but that wasn't entirely cloud stuff, so I haven't really. There's whole talks on SolarWinds, right? So I'll just skip that for today. Microsoft was notified by a customer who said, "I'm seeing weird things in my Exchange system," which is a little disappointing. They stole Microsoft's consumer certificate authority signing key, and if you know encryption, that's a super bad thing to have missing. Right, and then that's the thing that the Microsoft account MSA service is the one that actually runs authentication for everything consumer platforms, Xbox, Outlook, Exchange. That's a really bad theft. Microsoft still isn't sure how that happened. They did originally post that they think that that's maybe a crash dump, and they later realized that no, that crash dump didn't actually include that. So we're not sure yet. They're still looking into that. The attacker then used that key to forge tokens to access Outlook Web Access, and the breakout box here. They accessed user email from approximately 25 organizations, including government agencies and related consumer accounts in the public cloud. I think terrible, frankly. I mean, that's kind of the worst case scenario. Why did this happen? It's because the developers in this quote out of their postmortem, developers in the mail system. That's people who are developing Outlook.com and Exchange Online, assumed that libraries they were using performed complete validation and did not need to then add the required issuer and scope validations. They did not validate, right? Which actually violates what? Zero trust, right? You have to continuously validate and always evaluate these kinds of connections. And Microsoft says that they took actions to help prevent that. The real question I have here is why was that thing not in a hardware security module? Those keys are not supposed to leave an HSN. Which is the thing that actually protects those keys from this type of incident, right? I think a lot of us have that question without a whole lot of answers. Again, 2024, we saw Microsoft breached by this time a Russian team. Midnight Blizzard, same folks that actually got SolarWinds. January, they broke into the corporate email, and then they got some passwords that Microsoft had emailed to their customers. So Microsoft was emailing passwords to their customers. They took those passwords and then they sprayed them against everything Microsoft and found a test environment that let them in with one of those passwords. That test environment then had access to the Microsoft corporate environment. Why? Don't know. That person was able to access the corporate email accounts, including the members of our senior leadership team and employees in our cybersecurity, legal, and other functions. And they took a bunch of emails and a bunch of attachments. So we're now seeing them turn around with that information and spray it some more. So these guys are noisy. They don't care who knows. They're just looking for any way in. And when they find it, they just use it right away. There is a really cool analysis that Wiz wrote up on this. I'm not going to go through all this end to end, but you should definitely, if you're into how this sort of thing works, it's a really good write-up from the Wiz team. Okay, what can we expect in the future? We're wrapping up here. I think we should expect little change. So kind of the concept here for this talk is what is not changing. Misconfigurations by cloud customers, that will continue. The best way to get ahead of that is to look at the configuration that you're shipping to the cloud. We still see, unfortunately, a lot of enterprises just logging directly into the console and making changes in production, right? And nowadays, that's not the way you're supposed to do that. You really should ship everything through that build pipeline again, so that we can proactively test. We can go through the code and say, is this really what we want to wind up in production? Let's make sure. Confusion about the shared responsibility model. This happens not only from an operations perspective, it happens also in marketing, right? We see people say, I run my workload on Google Cloud and they have FedRAMP and HIPAA and PCI, so our application is good, right? And like, no, that's not the way shared responsibility works. Just because a cloud platform has HIPAA, is compliant to HIPAA or has a PCI certification, doesn't mean you can put healthcare data or payment information in that particular application. That particular application has things to do too. Oh. My battery dies. Okay, well, we're almost done, so let's see if we can go. All right, so supply chain attacks, we just talked about a couple of those with SolarWinds. We're looking for things like these privileged tools, because those things have access even beyond. So if you can hack one thing, you can actually hack hundreds and thousands of things, right? So that's kind of the goal of some of these, especially the espionage teams that are really hitting this with intent. Going to continue to see data and secrets exposure, unfortunately. Emerging, you're going to start to see these attacks be AI powered, right? We've already seen, I think, on LinkedIn some of these videos. And you get phone calls, and it sounds like your mom, and she's calling from a Mexican jail, and she needs, wire $100 or whatever. Give me some Amazon gift cards. And then you're going to start to see that in the cyber realm as well, right? The emails are going to be less easy to spot. The phishing emails are going to now be well written, because it's not English as a foreign language kind of thing. It's going to be AI writing those for them, right? Already starting to see this kind of in the wild. This last one here, I think, is kind of interesting. This concept of ransom cloud. Ransomware we didn't have a ransomware slide because it's not really entering the cloud market quite yet. But I think once it gets there, it's going to be very viable, right? And this is just kind of one where you log into Outlook Web Access and you find that all of your emails been compromised because you were tricked into allowing like an OAuth app access to your account, and now it has access to do these things, right? So send us Bitcoin if you want to get your email back. Okay. Closing thoughts, just some advice, just kind of like if you look at the whole series of things that happen in this deck, my suggestion is you buy more than you build, right? We see there's a lot of career resume driven development that's happening in the enterprise still, right? People are saying like, I want to write this cool thing. Like, okay, that's fine, but you should not create your own crypto modules. You should not create your own identity and authentication platform, right? Like go reuse these things instead of trying to build these yourself. Less DIY. Go see if you can actually buy your way out of this problem. Make it somebody else's problem, somebody else who's actually really, really skilled in doing this. And then get a hardware MFA key, right? A multi-factor authentication, one of these YubiKeys. YubiKeys are our favorite. I really strongly suggest that. It is the very tip top of the food chain in the NIST authenticator write-ups, right? If you go look at the authentication assurance level, the AAL, those things go straight to the top. It's the best kind of MFA you can get. As you may know, the text that you get on your phone is really easy to intercept, right? If you can call it, that's a social engineering exercise to get your carrier to flip your SIM and your phone to somebody else's phone, and now they have your MFA. So if you're protecting something and you really care about it, actually, not even that, just put this on everything is the way I do it, right? So you've got one that actually teeny tiny, just fits into your laptop. It is way even easier to use than the clunky apps that we have to pull out your phone and go find your app and look at the number and punch it in. This thing, you just touch it. It's literally just a fraction of a second to use. And then they got the ones with the NFC that you can actually like put on the back of your phone and use as a hardware key as well to authenticate. Super useful. It's a one-time purchase. To me, this is the highest ROI of any security control ever, because it is a one-time investment and it continues paying off. And it basically breaks phishing. Right, this is the phishing resistant MFA. Google actually proved that they rolled this out to all their employees and they never saw any phishing after that. I think that was like in 2012 or something. All right, so get a password manager, please, and get a secrets manager for your applications. Inventory and inspect your public code repositories. There's stuff out there, right? If you're a big organization, you've got stuff probably in public code repositories that you need to take a look at. Harden your cloud tenants. If you're confused on how to do that, or you kind of want a high level overview, here's a free blog just called How to Harden Your Cloud Services Urgently. This is my last slide. So.
No, it's all fine, Bill. I'm going to try the Dell power supply on the IBM. So to everybody online and everybody here, we'll see what happens. But
I got my water. I'm ready to throw on. Is that right? Is this an A, B, or a C type? I don't know.
Yeah. But as you were, sir.
Okay, so sorry, folks online, but
Fix some troubleshooting too.
okay, so hardening cloud tenants, turn on those security services. In a lot of cases, we talk to people and like, I didn't even think to turn that on. Then we go, well, cool. And you turn it on and it's full of red. It's like, well, I mean, these are things that you can address, right? Which I guess is good news. And then the last one here, prevent misconfiguration and secret leaks. And you're like, sure, Aaron, that sounds super easy. It's not, right? But it's something that you have to start looking at and getting better at, right? Figure out where are the secret leaks coming from? How are these misconfigurations entering our environment? Really, the encouragement here is to do this on a proactive basis and do it as code rather than chase around these problems and fires that are actually living in production, right? They will never end because that's coming from somewhere, right? So if you can convince people to stop making changes in production through the console and start shipping their changes through this code-based change management process, not only is that great for development, it's great for auditors, right? Because auditors come and they sit down and say, what changes ever happened in this environment? And you go, start here, start reading, right? Every change that's ever happened in this environment is logged right here, right? That's really hard to do if you say, well, I open up this thing and then I click on that thing and then I click on this thing and I go over here and log into this thing. That's really, really hard to follow. It's also hard for new hires, right? That it really raises the barrier for entry for new hires to come in and go, I don't know how to do what you just did, right? I can't repeat your exercises that you did just to set this system up. But if it's written as code, well, now I can, it's kind of hard because it's as code, but this is exactly how it happened. This is exactly all the configuration. And once you learn how that works, you're done, right? You understand exactly how to that reproducibility that you get by building this code.
I think it worked.
I think it worked. Cool. Thanks. I'm on my last slide. We had enough battery for that. I know that was a blast, but that was only like 12, 14 years of stuff.
Time for a question.
Time for questions.
Yeah, for sure.
The FBI has arrived at the Amazon offices with a search warrant.
Yeah.
Surveillance warrant.
Okay.
You want to get into my account search, you can do it. They think I'm doing some shady stuff.
Mhm.
What can I expect as a customer of AWS based on what you know? What's going to go down? Will they allow the FBI in? Will they allow them to install something on my PC too? They will allow them in.
I'm
Yeah,
grokking your question.
So will they allow them in to see my stuff and explore my EC2, see what kind of services I have configured, what my security policies are, VPCs, who they're connected to, all that stuff? Will they allow them that level of visibility without telling me?
Okay, so if you can't hear that online, the question is about legal access, right, to cloud, to data that's in the cloud, right? So number one, you have the choice of putting the data wherever you want, right? So if you have specific things to protect, the easiest thing is to pick where you put it, right? Now, these cloud companies, all three that we mentioned today, they're all U.S. companies, right? So they must abide by U.S. law, right? So they don't really have any choice. What they can do though is fight it, right? To say make sure that you have a reason to come in. The other thing that you can do, and it's probably the best answer, And the CTO of AWS, Werner Vogels, has said as much. He said, my goal is to be able to tell the lawful intercept team, I can't provide you that information. I don't have access to that information. I have access to encrypted information, but the customer holds the end key, right? That's the best thing you can do with it. If that's truly a concern, right? Is you can manage the keys yourself. And nowadays there are services that allow you to have your keys even outside the cloud and bring those keys in BYOK, right? You can bring your own key now to encrypt that whatever types of data or all the data. And then there's also confidential compute, which actually lets you keep those workloads encrypted even on the virtual machine, right? Even in use, right? So that's kind of the emerging side of that technology. So because yes, you can encrypt things and then you can put it in the cloud. Well, then how do you do anything with it, right? So you have to be able to share that key with something on the compute layer at some point to be able to decrypt that and then take action on it, do some analysis, and then put it back. Right. So conceptually, there is a place where that is decrypted.
So let me try the question with another way.
Yeah.
I just have basic authentication set up on my AWS account. I've got 15 seats with a bunch of people stuff. The FBI shows up for warrant, they walk in. They're at the gate. Will AWS allow them to go into the gate? And then once they're in the gate in my account and my interface, when you go through it, just start clicking on stuff and turn things on and off.
Clicking on stuff and turning them
That's
on.
the question. Yeah.
Okay.
Because I'm trying to figure out if that's happening from that perspective, that means insiders at AWS have the same capability to do just what they did in that first example.
Okay. Yeah, lots of stuff baked in there. So
The admin gods is what I'm talking about, right?
Right. So there's a big white paper on how cryptography works at AWS. So you should definitely read how it actually takes a quorum to unlock those keys, meaning like more than one person has to make that decision. But your question is about lawful intercept, and so if it is lawful, again, they are a U.S. company, have to abide by that law, but they will say like absolutely not until you can provide this information. You can't just say here's a bad thing wrong. You can't do that. You have to have run. You have to have
There's a whole set of forms you have to fill out.
yeah, the whole string of stuff that you have to have. So it's not going to be a brute force entry kind of scenario. It's going to be they have reason and they have the authority to do so. But again, the best way to do that is for them to be able to say you can have a look around, but you're not going to be able to see anything. We can't access our customer data. And then your other question was about like kind of the God mode of an AWS employee. Those are the separation of duties is very explicit and very intentional inside any of these cloud companies, right? So the separation of duties is substantial. I think you would find. I think I've seen the EC2 console once, but essentially the people who have access to the data plane do not have access to control. Hopefully,
a little better tonight.
Hopefully that answers your question.
I took the AWS security specialty last year and passed that, but we didn't have any discussion about this.
No, yeah, I would imagine they didn't. Yeah, that's I mean, at the end of the day, like
but it helps us to understand what the attack surface is. That's what I'm trying to get to.
Okay.
What the attack surface would look like from the inside. I'm very interested in insider activity.
Yeah.
Forget about
Okay.
millions of dollars spent outside.
Yep. Yeah, good. So then last thing I'd say is like walk up to an array and figure out which of these hard drives belongs to S3 and which one has the data on it. It's
Right.
like monumental things. Question back here? Cool. So the question is about ransomware in the cloud. Why haven't we seen that yet? I think it's so successful on-prem right now in the data centers that there's not really been a reason to pivot, right? When you can take a whole casino down and then the next casino, right? That seems to be working very well. So I think eventually, right, we'll start to see that in the cloud environment. Your specific question around like OAuth. Right, and that's kind of that's some people are raising the flag early, right, and saying, hey, that's probably going to be a thing, right? So I think it's in our future here. So and the kind of the scarier part is that within a cloud environment, if you have that kind of root level access, and especially if you thought about it ahead of time and you planned your attack, the scripts run extremely fast, right? You can do a whole lot of damage in a very short amount of time. In this video, actually, Kevin Minton walks through what that example is, kind of a proof of concept that we walked through how that works. And it is, it just goes, right down your email box faster than you could do anything about it for sure. So I think that is kind of in our future. And the next question was, are cloud providers air gapping, the data? I wouldn't say so much air gapping in the cloud. The way we do that is we use versioning, right? So, there are previous versions of the object that you can go recover, especially with cloud managed services, right? Like RDS, relational database service that's gone back into the database, or Cloud SQL and Google Cloud. They're responsible for taking those backups and making the data available to you. So are we going to see that? I think so. Yeah.
There's a data breach, cloud. Who's responsible for the data? Or the cloud?
Great. So the question is, who's responsible for a breach in the cloud? And that was actually one of the very first slides we had up here. It depends on where the breach was, right? And we've seen breaches on both sides. We've seen breaches on the cloud provider side, right? Because those last two examples we showed where Microsoft's key was taken, where they were able to get into customers' emails. That's clearly a Microsoft issue, right? And then we've also seen where people in this talk today, we talked about how some of those S3 buckets are configured with public access. That's a customer problem, right? So it really can be on either side of this fence here. True, yeah, because essentially you are outsourcing services to a third party to manage those controls for you. So ultimately, it is the company's responsibility because that's the provider they choose. Good question.
Yeah, I suppose there's the bit of technically who was at fault, but and it's your customer and their perception. Yeah.
Yeah, you can't take that back, really. So
This is why you don't let developers configure security control policies or ACL. Exactly that.
Yeah. Or marketing.
No offense.
well, you do, but then you run through the pipeline to test it. See how well they did.
Yeah. Any other questions? We did have one question online, actually, for Bill. Someone was asking for some more info about the ISSA elections. But
Take it away, Bill.
stay here, Bill.
Okay, I've been asked to repeat and to enunciate better the ISSA.
To the mic.
To the microphone, speak to the microphone. Next Thursday at UTC at 11:30, ISSA's monthly meeting is taking place. And we've got a great speaker. We have John Kim from the FBI. He will be presenting. But all of our board positions are up for election now. If you are an ISSA member, you should have gotten an invite to it. If you're not, shame on you. You can go to sdissa.org and you'll find out all the information.
Awesome. Awesome. Yeah, and the elections are open up to anybody. What we were saying earlier is if you're someone who's been around the moon enough times and you want to bring that experience, or if you're someone new and aspiring and want that opportunity, that's available for you as well. Thank you.
Thank you.
Cool. And again, that was awesome. There's multiple platitudes in the online chat.
Sweet. We got some other stickers and stuff.
Stickers in there that
That was so awesome. You squeezed so much into such.
Yeah, it's fantastic.
He has more to write about. I thought, I want to tell the story of like kind of cloud into end. I really didn't think about what I was putting on. So
Slide out. Like from the cloud practitioner perspective, it would be like a great intro. Part one for that type of curriculum.
that would be cool. I felt like I could do a whole semester class on that.
Yeah.
Get the PDF is on that machine, so you can put it wherever you
I'll have to get it from you because it's actually the school's machine.
Okay.
So, yeah. And we did record this. Are you cool if we share that online as well? Awesome.
I think I said something nasty about
Cool.
All right.
Any other questions? Sure. Thank you. Well, thank you again. That was fantastic. Yeah, very much appreciated.
Thank you so much.